What breakthroughs do you think we might have in your space in the next few years that'll make headlines?
We will see, I think we'll see lots of things, and you're sort of starting to see them in research papers already because the field's moving so fast. I think we will see in the next few years, you will see biologics that are designed on a computer that make it through to clinical trials. I think that's coming. There's already one company that sort of talked about doing that, but they designed only part of their molecule. But they did design some of their molecule and it, going through to clinical trials with it. And I think we will continuously see the rise of the computational technique being the driver of the experiments that are chosen to be done, and then the driver of what happens in the clinical trials. Hopefully that will translate into lots of other good things in terms of drugs becoming easier to make and more available. I think we will start to see, and this is something, maybe this is a hope rather than I know it's going to happen, but I think it's a really key hope for somebody like me, is that we will start generating data sets with the algorithms in mind. So in my space at the moment, the data we have is this historical data that people have collected because they were interested, say, in a specific antibody or a specific target, and they published this. And you collate all that together and try to use that to train algorithms. But if I was designing a data set, those are not the experiments I would have carried out. Now, experiments are expensive, and they're hard. But we're moving to a much more roboticized setup of all of these types of things. So I think one of the things that we will see, and it will change the kind of types of algorithms we can even write, is if we collected the right data in the first place. It's a bit like lots of my colleagues in this department, they're statisticians. And one of their biggest complaints is when somebody turns up after they've done all their experiments and say, can you do some stats on this to show that this is significant? And it's like, well, I could have done if you talked to me before you ran the experiment. It's quite hard now to do anything with your data because you set that up kind of as you thought about it, but not something that was computationally or statistically would allow me to make those kind of statements. And I think we're starting to get to the stage where people are thinking, how do I generate data that really drives machine learning algorithms? And that, I hope, what we will see as the big breakthrough is that will be a virtuous cycle, in the sense that once you do that, the algorithms will get noticeably better, then the data collection will get noticeably better, and you will really, you'll see a massive acceleration in what's achieved, I think.